This video is about the subtraction of whole numbers. We'll talk about the meaning of subtraction, the fact that addition and subtraction are inverses of each other, various subtraction algorithms. We will mention subtraction with bases other than base 10. And we'll talk about some mental computational skills and estimation techniques that are applied for subtraction. You'll see that subtraction, both the section in your chapter, the homework assignment, the number of PowerPoint slides, probably the length of this presentation is going to be less than the similar one for addition. That's because the two are so similar. We can model subtraction in several different ways. Perhaps the most common model is the takeaway model. This is a model that relies on set theory. This views subtraction as a second set of objects, we could even say a subset of objects, being taken away or removed from the original set. So if Juan has 6 cookies and he eats 3 cookies, how many cookies does Juan have left? That's a takeaway model. A number line model is very similar to the model for number lines for addition, except we're moving left rather than right on the number line, and we start at the number we're subtracting from, not from 0. And then the missing addend model. This is an algebraic type of reasoning. Please don't think of algebra and think that's inappropriate for elementary school students. Algebraic reasoning goes throughout the elementary curriculum, and it begins with questions like 10 minus what number is 8? Or 2 plus what number is 7? Those are algebra methods. Those are algebraic thinking. We use usually in elementary school a box rather than an X, but it's the same thing. Students that have repeated meaningful exposure to algebraic thinking in elementary school and middle school will do better when it comes time to take pre-algebra and algebra 1 and beyond. So here we have a quick example of the takeaway model using blocks. And of course, this uses blocks. In your classroom, you could use counters, you could use chips, you could use toothpicks, you could use straws, you could use any sort of model. It doesn't have to be pre-made commercial models, although those have some benefits of being durable and stuff like that. Here's our number line model. So here is 5 minus 3. So here's how it works. I oversimplified a little bit at the start of the video. We start at 0 and then we move to 5. Personally, I would just start at 5, but that's just me. And then from 5, we move 3 units back to the left. And so this tells us then that 5 minus 3 equals 2. So this is a good model to use for your homework when you have to draw this. Follow the model. It looks like this when you do your homework. So this is what this is the typical problem looks like in a classroom, right? 8 minus 3 equals what? But we could look at this and think of this in another way. We could think of, if I have 3, what do I have to add to it to get to 8? If I have 3 blocks, how many blocks do I need to have 8? So it's the missing addend in this equation. 3 plus something is 8. And so we could show this using sets. Notice we have cardinality of 8. If we were to have 3 remaining, how many do we have to take away? We could show on a number line model, if we start with 8, but we're then 8 minus 3 is what? So we need to know that 3 plus something is 8. And so here we can just count 3 plus 1, 2, 3, 4. You can't see me count there in my pointer. So we can just count 3 plus 1, 2, 3, 4, 5 is 8. So there's our definition. And notice how we define subtraction in terms of addition. A minus B is the unique whole number C such that B plus C equals A. That's all subtraction is. Subtraction is adding a negative number. Another model that we might use is a comparison model. Juan has 8 blocks and Susan has 3 blocks. How many more blocks does Juan have than Susan? So we're comparing two sets. Remember that addition is closed. If we add any two whole numbers, we will get a whole number. Subtraction is not closed. Now, we as adult learners know that we can take 2 minus 7 and we get -5. But -5 is not a whole number. -5 is an integer. So if if we are doing a minus b, and a is smaller than b, then our answer is not going to be a whole number. So therefore, subtraction is not closed on the set of whole numbers. These number sentences could be true or false depending on what we said the symbols stood for. Right? Obviously, in our number system, 9 plus 5 is 14. But we might not ask that. We might say, is it true or false that 9 plus 5 is 15? Is it true or false that 9 plus 5 is 45? Is it true or false that 9 plus 5 is 12? Similarly, 12 minus what is 4? 12 minus 8 makes that a true statement, but we could put other values in there that would make it a false statement. So the value that's used makes the equation true, it's a solution. If it doesn't make the equation true, it's not a solution. Just as with addition, we should also begin subtraction with concrete models. And one such approach are base 10 blocks. Those don't have to be the only approach used. When I was regrouping with subtraction, which I remember being, for me personally, was in 2nd grade, and I don't know if that was typical at that time or not. But my teacher used paper milk straws that we had at lunch and stuff all the time, and just used rubber bands to group them together. We didn't worry about hundreds. I don't think. It was just individual straws were 1 and wrapped straws together were 10. And she might have had 1 or 2 that she had 10 wrapped together to get to 100. You could do the same thing with craft sticks. You could do the same thing with all sorts of different objects. It doesn't have to be base 10 blocks. The base 10 blocks do have lots of purpose. If you happen to be in a school that has math manipulatives, you should take full advantage of them. And if you happen to be in a school that ever has the money to buy math manipulatives, you should advocate for that, would be my suggestion. So here we have a concrete model. This is going to go over a few slides here. What we've done right here is we have illustrated 243. Again, at times you're going to be asked to sketch this out. And so you would just sketch, just like I said with addition, you can sketch this very roughly to be a flat, a long, and 3 units. You do not have to be nice and pretty and have the lines like they do here. That is not needed at all. So to subtract 61 from this, we could actually even, sometimes we'll actually model the 61. You might actually draw it underneath it. But what we notice is that we can do that here. We could subtract 1 of these. We would have 2 left. But I can't subtract 6 from these because I only have 4 of them to start with. What do I need to do? I have to trade. I have to trade 1 flat for 10 longs. So here's how my trade is shown. Notice what we do is we just draw a circle around, or a dashed line around what we're trading, and then we show what it works. So now from this, we can take away 6 longs. And I will, there we go, they're X'd out. And we've taken away 1 unit. So what do we have? We are left with 1 flat, remember that's 100, 8 longs, that's 80, and 2 units, which is our number, 182. So just as with addition, we want subtraction to start with concrete models. Now, that's going to start with things like counters, like when Jose has 3 apples and then Norman gives him 2 more apples. How many apples does Jose have? Stuff like that we start with. But when we start to things where you have to regroup in subtraction, which sometimes used to be called borrowing. We don't usually say borrowing anymore, although some people probably still do. I would probably still slip now and then. Um, Models like this are also very important. So again, we're always working towards the standard algorithm, but there are other possibilities along the way. One alternate algorithm is called the equal additions algorithm. This is based on the fact that if we add the same amount to both numbers, we get the same answer. So 255 minus 163. So if I start by adding 7 to both numbers, why am I choosing 7? I'm choosing 7 because I'm choosing 7 for the purposes of this bottom number. 170 is going to be a pretty nice number for me to work with. So I add 7 to the bottom number. I also add 7 to the top number. And then I still would have to borrow here, so I'm going to add even some more. I'm going to add 30 to each number. So now I have an even nicer number to work with, 200. I have 292 here. 292 minus 200 is 92. And then for subtraction, the counting up algorithm is similar to making change. And it's the way that a cashier or a teller who has been trained how to give change correctly gives change for purchases. It is not commonly used as much anymore, but it is a way to do mental subtraction. And what it really does is encourages students to count up to nice numbers, multiples of 10, 100, and 1,000, much like our currency system, our money system uses. So for example, subtract 100 minus 31 using the counting up method. So we start with 31 plus 9 equals 40. And then 40 plus 60 equals 100. And so 60 plus 9 is $69. And this is how a cashier might make change if they were giving a person, say, ones and tens. So they might say, okay, the cost was $31. You gave me a $100 bill. Here's your change. So they might say something like 31, 30, and then 32, 33, 45, and to count out 9 ones get 40, and then count out 6 tens to get to 60. Your change is $69. So here's an example. Noah owed $11 for his groceries. He used a $50 bill to pay. While handing Noah the change, the cashier said 11, 12, 13, 14, 15, 20, 30, 50. How much change did Noah receive? So what the cashier says when she says or he says 11, Noah's gotten $0 back. And then as the cashier gives Noah his change, they say 12, that means $1 more, 13, $2 more, 14, $3 more, 15, $4 more, 20 is an extra $5 then. So 1, 2, 3, 4, 5. 4 plus 5 is 9, and then 30, that means a $10 bill was given, and then 50, a $20 bill was given. So Noah would get $39 back, which makes sense because 50 minus 11 is 39, or 50 minus 11 is 39. And then we have the trades first algorithm. This is very similar to the standard one, except we regroup first before we do any subtraction. And so let me just write an example of this on here quickly. So what we do here is, so this is 215 minus 46. That's supposed to be a 6 on the bottom. And we see that we're going to have to borrow, or regroup, I should say. I told you I would say borrow by mistake at some point. And so what we do is we regroup even before we start subtracting. And so there's different ways we could do this. I'm taking the example from your textbook with a different number. It's on page 133 in your book. But we might begin by something like this. We would write out 215, understanding as hundreds, tens, and ones. And then the first thing we immediately do is we trade one of our hundreds, and we add that to our ones. So we traded 100 for 10, or sorry, add that to our tens. We traded 100 for 10 tens. So now we have 11 tens. And then we know we're going to have to trade again. So we take one of our tens and we bring it over here and we get 15 ones. So I now have 100, I have 10 tens, and I have 15 ones. And then from this, I can subtract 46 and I get 169. And we'll check our work really quickly. 169 plus 46 should equal 215, and it does. So let me mention one thing before I forget it, because I was going to mention this in the last video and I have completely spaced it out. When we started talking about addition facts like 2 plus 4 or 8 plus 8, and we talked about things like doubling and other things, none of this implies that students shouldn't eventually memorize their addition facts. Memorizing addition facts, knowing that 8 plus 7 is 15, is going to be quicker for students than saying, well, 8 plus 8 is 16 and 16 minus 1 is 15. Now, being able to do math like that is going to be really helpful for students in the future. So it shouldn't be discouraged. Rather, it should be seen as an important step along the way of being able to just know those facts in your head. So developing understanding is incredibly important, but it is also worthwhile. It will help students if they know the facts as well. But there's lots of research that shows drilling students on math facts before they understand what's going on does not lead to long-term success. It might lead to short-term success, but it doesn't lead necessarily to long-term success. So I want to mention that last time with addition facts. The same thing is true for subtraction facts. So here's an example of bases, a subtraction of bases other than base 10. I'm not really going to talk about this because I think you'd be much more likely to ever be asked to add in other bases than you would be to subtract in other bases. In any case, what you would end up still having to do is different types of regrouping and stuff like that. But the regrouping is going to look different because it's in a different base. It's for us, for this course, I think it's more complicated than it's actually worth to go through for subtraction. Again, one way to do this also, and the way that I would almost certainly end up doing it if I had to do this on a test in a test situation, is I would convert both of these to base 10, which you can do after 3.1. Then I would subtract in base 10 and convert my difference, my answer, back to base 5. And then some mental computation techniques. Breaking up and bridging. Again, I can kind of do whatever I want as long as I do the same to both numbers I'm subtracting. So but rather what we're doing here is we're breaking up the second one. I was misunderstanding what they were asking for a second there. So we start by saying, oh, this is going to be 74 minus 20. And then we're taking the other 6 away from that. So 74 minus 20 is 54. 54 minus 6, we get 48 for our answer. We could also do trading off. So here we're adding 4 to both of our numbers. That does not change the value. So we get 78 minus 30 equals 48. You could also, and trading off can go with either addition or subtraction. Just addition is usually easier for most people to do in their heads. I could also have subtracted 6 from each value. And so 74 minus 6 is 68. 26 minus 6 is 20. And I get 48. We could also do what's called dropping the zeros. This is, notice this is a different problem. This is not still 74 minus 26. This is 7,400 minus 600. And so when we drop the zeros, we just look at what's 74 minus 6. And we say, oh, that's 68. And so that means that 7,400 minus 600 must be 6,800. So there's subtraction. Hopefully that will be helpful for you as you work through the chapter. If you have any questions, let me know.